Okay, the last method we're going to talk about solving quadratic equations is using the quadratic formula. So I've placed a quadratic equation, and I'm going to use completing the square to solve this equation for x. So first off, I want to divide every single term by a. Now, I want to rewrite now on the side here, I'm going to complete the square. So what? Half of b divided by a. And then I'm going to take that answer and square it. So now, what am I going to do? I'm going to add b squared divided by 4a squared and minus b squared over 4a squared. Now, if you recall, with this trinomial, it is factorable. If we complete the square right, we can use the first part of completing the square. So this will factor as x plus b divided by 2a squared. Now, c over a minus b squared over 4a squared. Well, in order to add or subtract fractions, you need an LCD. The LCD, 4a squared. So that means each of my denominators are going to be 4a squared. So again, what do I multiply this denominator by to get 4a squared? And that's 4a. So 4a times c is 4ac. Notice the denominators are the same, so my numerators will be the same. So when I subtract these two fractions, I get 4ac minus b squared divided by 4a squared. So I'm going to put plus 4ac minus b squared over 4a squared equal to 0. Now I'm going to subtract this entire term. Now remember, if the whole thing is negative, so let me show in a different color, I need to distribute the negative to both of these terms. So I will do that, but I'm also going to switch these two terms around. So negative and a negative, that's a positive b squared minus 4ac all over 4a squared. Take the square root of both sides. Now, the square root of 4a squared is 2a, so I do not need to rationalize here. I'm going to subtract b over 2a. Well, because they have the same denominator, I can rewrite it as 1. Now, take a moment and take a look at what x is equal to. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Does that formula look familiar to you? It should. This is the quadratic formula to help me solve quadratic equations. So my quadratic formula, as I've written out already for us, is x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, given you have a quadratic equation that is set equal to 0. Okay, so let's use a quadratic formula to solve each of these equations. Remember, you want to have these quadratic equations set equal to 0. So I got to add 3. Okay. Now, a is 2, B is negative 4, and C is 3. Okay? All right, so now the quadratic formula. X is equal to the opposite of B plus or minus. Okay? Square root of B squared minus 4AC divided by 2A. So now you know what A and B and C are, so let's plug in. So the opposite of 4 is 4. That is negative 4 squared, that's 16, minus 4 times 2 times 3, all over 2 times 2. Okay, so we have X equal to, as I move up slightly, 4 plus or minus, well, this is 16. 4 times 2 is 8, minus 3 is times 3, excuse me, is 24. And 16 minus 24 is negative 8, all over 4. Now, I can pull out a perfect root of 8. We know because there's a negative underneath, it's going to be in terms of I. So the square root of negative 8 is going to be 2 times the square root of 2 times I over 4. Now, every single one of these terms, I can factor out a 2. So that's going to be 2 plus or minus the square root of 2i over 2. Now, you can divide each term by 2 from here and have 1 plus or minus the square root of 2 divided by 2i. Either one of those answers would be fine. Okay, so let's take a look at the other example that's on the top right of this page here. First of all, this does not look like a quadratic equation. So I'm going to distribute the n and then subtract 1. Okay, let's identify A, B, and C. A is 1, B is negative 2, and I'm going to put C down here as negative 1. Okay. All right, so the quadratic formula. Now again, notice it's an n. So I'm going to put n equal to instead of x. It doesn't matter whether it's n or x there. But you are solving for n, so it should be n there. So we go back to the opposite of 2, that's 2, plus or minus negative 2 squared, that is 4, minus 4 times 1 times a negative 1, all over 2 times 1, which is 2. Now it's minus a negative, that's 4 plus 4, that's 8. So it should be 2 plus or minus the square root of 8 over 2, which is the same thing as 2 times the square root of 2 over 2. And now I can divide every single term by 2. That's 1 plus or minus the square root of 2. Now again, you know you can separate these two solutions as 1 plus the square root of 2 and 1 minus the square root of 2, but I will not do that in this video. Okay, so let's solve this formula here then. Now again, when you first take a look at this problem, it looks awfully difficult to solve for I, until you realize that you have a quadratic equation here. Notice, you have this term that has I squared, this term has I to the first, and that's a constant. That's a quadratic equation in terms of I there. So what I would like to do is get this equation equal to 0. So I'm going to add the ri squared and subtract ei on both sides to have this. Now, using the quadratic formula, well, A is equal to R, B is equal to negative E, and C is equal to P. Yep, we are allowed to do that. Having variables as being A, B, and C, that's fine because there is no numbers. Okay, so the quadratic formula. Now again, I'm solving for I, so I'm going to make it I equal to the opposite of B plus or minus B squared minus 4AC all over 2A. Okay, so the opposite of E is just E. So it's negative e squared, that's e squared, minus 4 times r times p, all over 2 times r. This is the one nice part about formulas. There is nothing to simplify here. I cannot simplify e squared minus 4rp because of the fact the factors would not be the same. We are literally done with this problem. So again, the quadratic formula comes in handy to solve quadratic equations. Completing the square does exactly the same thing, but it also gets us to a perfect squared trinomial form that we will use later on. See you in the next lesson.